And the way I'm going to do this is like today it's going to be all pre-calc, okay? And then tomorrow it's going to be all calc, okay? So a lot of this stuff is today is review, okay? So we start out with this first slide, okay? It comes straight out of my pre-calc notes. Do I need to explain any terms in there at all? The angle theta that's in there is really this angle here, okay? Let me be kind of explicit because Bill Gates wasn't very cooperative with me. So this is theta. That's theta, okay? All right, so since you're okay with that, so today's topic is really inverse trig functions, okay? As it tells you in the agenda there. And we really cannot talk about inverse trig functions unless we restrict their domain. So remember what a trig function looks like, okay? So for example, the sine function looks like this. Okay? Why can't I talk about the inverse of this function? Why doesn't it make sense to talk about the inverse of this function? Yes, Henry?
Because the angles go that odd.
What do you need for an inverse to exist? You've done this in algebra 0, 1, 2, and in pre-calc and in calc. You've seen it fine. Sorry? It doesn't pass the horizontal line test. So how can I talk about the inverse of this? Well, I can if I restrict the domain. Okay, so if I take a look at the function from here to here, and I know this is pi over 2 and this is minus pi over 2, and the reason why I know this is because these things are my friends. I live with them, I Facebook them daily, I game with them, okay, 24/7. They're part of me, okay, they're part of me. So notice that blue function, does it pass the horizontal line test?
Yes.
Okay. Notice that it also looks like this. It's the same all over. Look at it. It's the same all over. It's the same here too, except it's flipped over. You guys with me? So that little blue graph describes the entire sine function. I can restrict the domain, and now I can talk about the inverse of it. Okay? So you know that the inverse function is written like, in this case, sine inverse. Okay? The book uses the term arc sine. Okay? So both terms are used. Your calculator uses this notation here. Okay? That's what your calculator does. Okay. You have also seen this table in pre-calc. Okay, I've seen it in pre-calc. You might want to copy it down, and you might want to copy the two factoids that are there, number 1 and 2. And I'll pose your, okay, from item number 2, okay, fill in this table. I don't know if I can get everything in there. Okay, so all you did was interchange from this table right here. The domain becomes the range of the other, the range of one becomes the domain of the other. Okay, so that's what item number 2 here was. Okay, that's what item 2 was. Okay, so notice that if I give you an arc sine of an angle, Which two quadrants is the answer going to be in for arcsine? Hello? Hello? 1 and 4 are cosine. One and, sorry, 2 and 3. Rachel? Okay, you guys? Okay, let's go through this. This is quadrant 1. This is 2. This is 3. This is 4. It's telling you the angle is between 0 and pi, so here's 0. Here is pi. So it's going to be 1 and 2. Right? Because in there the angle is between 0 and pi. And then tangent is the same as sine. Okay, the same as sine. Okay? So these are angles, or the inverse trig functions that we studied really thoroughly in pre-calc. Okay? In calc, you need to know a little bit more, and you need to know the inverse trig functions are cotangent, arc CSC, arc SEC. So go take a look at page 371 in your book, and notice the restrictions or the values for domain and range there. You might want to make that part of your notes, okay? So page 371. So it's this table here that, so it's got the extensions to COT, SEC, and CSC, okay, on page 371. I'm not going to spend time here right now on it. You've got a book, you can read that and make it part of your notes, okay? All right. Some more fond memories, okay? Your friends, one more time. It'd be nice if you put in another row in there underneath the theta row to give you radians. Okay, to give you radians. It'd be nice to do that. Because when you're talking about the inverse trig functions, we are always giving answers in radians. Okay, always giving answers in radians. So needless to say, you should know this. Jonathan, be careful you don't fall off there. There's a black widow roaming around there at the back, Jonathan. Yeah, and the black widow is not Shannon. Haha. When did that happen? When? I guess I'm not up to date on my stuff. Okay, number 9, page 377. Number 9, page 377. There we go. Arctangent of root 3 over 3 without a calculator. So you need to dig into your friend's table and get me an answer out of there. Henry, don't yell out the answer, okay?
always supposed to find the radian?
Yeah, you got to look in the table and tell me which angle has a tangent of root 3 over 3. Remember, the tangent's not in the table, so you need to do some division. Okay? Sorry? Pi over 6. Everybody with her on that? Yeah?
What number are you in?
Number 9. Okay? Next example. Number 18. Now 18a is straight out of your friend's table. Okay, you should be able to do that out of friend's table. B might not be, is not definitely not doable from the friend's table because those are not friendly numbers. So part A, tangent of, what's arc cosine of root 2 over 2? Friend's table. Sorry? Pi over 4, nice. Tangent of pi over 4, nice. Okay, all out of friend's table. 18. Okay. 1. Part B. Now part B is a little different because you can't go into the friend's table. However, arc sine 5 over 13. Is the answer going to be an angle or a number? Sorry? Exactly the opposite. Okay, it's an angle. When you get arc sine of something, the answer is always an angle. That's what we talked about. Which quadrant is it going to be in? Okay, so answer is always going to be an angle. I'm going to denote my angle by a Greek letter theta. Okay? So that statement is the same thing as saying sine theta is 5 over 13. These two are equivalent statements. Okay, they are equivalent statements. So you've got a triangle here. This is theta. Opposite side is 5. Hypotenuse is 13. Adjacent is 12. So part B is asking you cosine of theta. What's cosine of theta from the triangle? Yeah, 12 over 13. So do you see how you work those problems out? Okay. Not a friendly number, so you're going to do a triangle stuff. Okay, you guys all right on this? Next example, number 26, page 377. So this one doesn't have numbers, so it means it's going to be algebra. Number 26. Okay. And you're going to use the same kind of approach. We're going to say arc sine of x minus 1 equals theta. That means the same thing as sine theta equals x minus 1. Okay, those two are equivalent statements. Then you make a triangle. The opposite side is, the hypotenuse is, adjacent side is, nice. Okay, and this is equal to, would you be happy if I wrote this down?
Yeah, sure.
Okay, I have 4x minus 1 squared, got rid of the 1, leaves me with 2x minus x squared. Okay? So the question is asking, I want secant. I've replaced this guy by theta, as you can see. So secant theta is 1 over cosine. which means that it's going to be hypotenuse over adjacent. You guys with me on that? Okay, secant is 1 over cosine. And since cosine is adjacent over hypotenuse, secant is going to be flipped over. Okay, so it's going to be hypotenuse over adjacent. What's the hypotenuse in the triangle? What's the adjacent? 2x minus x squared. And the book doesn't expect you to rationalize this, okay? They are okay with leaving the square root downstairs. All right, you guys got this down? Okay, you good? Okay, one last example and then we are done. Okay, number 30, page 377. And for this one, you need a graphing calculator. So I want you to do parts A, and then I'll show you how to do parts B and C. Okay, number 30. So one more time, we're going to let arc cosine of x over 2 equals theta, which is the same statement as saying cosine theta equals x over 2. And then you get your triangle. Here's your angle. Adjacent is x. Hypotenuse is 2. Opposite is going to be, someone help me out. Sorry? Wait a minute. 4 minus x squared? Yeah? All right, and then what it's asking you to do is find tangent of theta. So tangent is opposite over adjacent. What's the opposite equal to? Adjacent. Right there. Okay. What about horizontal asymptotes? You guys graph that. You should be able to tell me what the asymptotes are. Emily, what are your horizontal asymptotes? Wait a minute. Remember, it's an asymptote, so it's going to be an equation. Erase one. Okay. What are those asymptotes? Well, where is the graph going towards as x becomes larger and larger and larger? Isn't it just y equals 0? Isn't this the isn't this the isn't the graph kind of going like this? Well, where is it going towards? Isn't it approaching the x-axis? What's the equation of the x-axis? Y equals 0. Remember, an asymptote is a line. It has to have an equation. So it's y equals 0. So everybody okay on this stuff? Okay? All right, you got work to do. And then tomorrow it's going to be calculus, okay? It's going to be calculus.